Hello children. Let us continue with the chapter Fractions and Decimals of Standard 7th. We have already started about the chapter and we are now going to solve more problems related to fractions. Here we are with the fifth sub-question of question number 1. Here you can see that there are three numbers, all of them are fractions and we are supposed to add them. The method is as usual. You will first of all find the LCM. The LCM of 10, 5 and 2 is 10. The method of finding LCM, that is the easier method, is you start with the highest numbers table. Here in the denominator you have 10, 5 and 2. So select 10 as it is the highest number. Now start with its table, that is 10 ones are 10. Now 10 ones are 10 itself comes in the table of 5 as well as 2. That means you get the number 10 in the table of all the three denominators. So we select the LCM as 10. Here we are making all the denominators 10 by multiplying the numerator and denominator of each term by particular number. After this, we get all the denominators as same. Once done, add the numerators and get your answer. Make sure that you reduce it. The next sub-question now. Here there are two numbers, both are mixed fractions and they are to be added. In such cases, whenever you have mixed fraction, the first step will be converting it into an improper fraction. So here we are there with the improper fraction. The first term, that is 2 integer 2 by 3, will become 8 by 3. And the second fraction, that is 3 1 by 2, becomes 7 by 2. Now we'll find out the LCM of 3 and 2, that are the denominators. Now let us start with the table of the greater number. Here out of 3 and 2, 3 is the larger one. So the table of 3 starts as 3 ones are 3. 3 is not there in the table of both the denominators. So let's proceed with the table. 3 twos are 6. Now this 6 is there in both the tables, that is table of the denominators. So we select 6 as the LCM. Next is making the denominators same by multiplying the numerator and denominator by certain numbers. Here the first term should be multiplied by 2 and the second term should be multiplied by 3 so that the denominators become equal to the LCM, that is 6. Now after getting the equal denominators, we will add them and we'll get the final answer. Next, the seventh sub-question. Here there are two mixed fractions which are supposed to be subtracted. The first step as usual will be converting it to an improper fraction. After that, you are going to find out the LCM of the denominators. Here the LCM is 8. Now make the denominators same. Here there is a subtraction sign, minus sign in between. So subtract the numerators and get the answer. The answer always should be in the reduced form. It is not compulsory every time to convert it into the mixed fraction. Now we'll move to the next question, that is arrange the following in descending order. Now that is the first sub-question. Now if you check the denominators, they are all different. With different denominators, we cannot directly identify or arrange the things in the descending or the ascending order. So every time the first step is making the denominators same, and the only method to make the denominator same is LCM method. So take out the LCM of all the denominators. Here the LCM comes out to be 63. Change the numerator denominator in such a way that everywhere the denominator becomes 63. For that purpose, the first one is multiplied by 7, the second by 21, and the third one by 3. This is how we have changed all the denominators to 63. Make sure whenever you multiply in the denominator as well as numerator. This is how the value of the number doesn't change. Now, whatever number we have got, that is 14 by 63, 42 by 63 and 24 by 63, it is now very easy for us to decide which one is greater and which one is lesser. We are now going to write them in the descending order, so we'll always start with the largest number. So it's written in the descending order, 42, then 24 and then 14. So the ratio, the fractions are written as 42 upon 63, 24 upon 63 and 14 upon 63. But these are not the actual values. So we are going to substitute them by the actual values that is there in the question. So let us write the respective fractions for it and you get the answer in the descending order. Let's check out for one more example. Again, you will see the denominators are not same, so use the LCM method to make them same. Here the LCM is 70. So do the corresponding changes, that is the multiplications to be done in the numerator and denominator in such a way that you get the same denominator. Once you get this, write in the descending order, that is from the largest to the smallest. But your question doesn't have these. We have to write the exact numbers that are there in the question. So substitute the equivalent fractions from there and you get your answer. Now the next question, that is question number 3. In a magic square, the sum of the numbers in each row, in each column and also the diagonals is same. Is this a magic square? Now, one square is given. To check whether it is a magic square, we always check the sum of each row, each column and both the diagonals. When all the sums are equal, we call it a magic square. So let's check out whether this is a magic square. So start with the additions. Here we start with the addition, that is the row 1. Let's add here. If you check all the number, the easiest thing is all of them are having the same denominator. That means the addition is very easy. So quickly add them up. Here you get 15 upon 11. For row 2, the addition again gives you 15 upon 11. The row 3 sum is also 15 upon 11. Now let's start with the columns. First column, second column, both of them are giving you 15 upon 11 only as the sum. Let's check out the third column. That is again giving you 15 by 11. Now it's turn for the diagonals. So add the first diagonal and then the second diagonal. Now if you have checked, everywhere we got the answer as 15 upon 11. That means all the sums are equal. Since all the sums are equal, we decide that this is a magic square. With this, we come to the end of this video. We have lots of examples to solve in the coming videos. Goodbye till then.